The mission readiness. And ladies and gentlemen, it's my privilege to welcome on stage our distinguished moderator, Air Vice Marshal Pawan Kumar, former DG DSA. Let's put our hands together to welcome sir. Inviting our eminent panelist, Mr. Srinath Ravichandran, co-founder and CEO AgniKul. A very warm welcome to you, sir. Inviting Mr. Ashok Saxena, CEO Space TS, warm welcome, and Mr. Jai Panchal, CEO Aule Space, to kindly grace the stage with their august presence. So warm welcome to the panel Responsive Launch and On-Orbit Servicing, Sustaining Mission Readiness, that focuses on one of the most critical dimensions of space security. Our distinguished moderator, Air Vice Marshal Pawan Kumar, retired former Director General Defence Space Agency, with deep operational experience in integrating space capabilities into the military frameworks, has played a key role in shaping India's defence space architecture and joint operational readiness. Sir, we are honoured to have you steer this critical discussion, and may I hand over to you to carry forward the proceedings. Over to you, sir.
Yeah, thank you so much for the introduction and for getting us here. I'm an Air Force guy, and they say the flexibility is the most important characteristic of air power. So the flexibility of this panel is that 3 people out of 5 didn't turn up. So, we have rearranged ourselves in last about 15 minutes. But I am very sure this is going to be a great panel. So first of all, on behalf of my panel and on myself, I would like to thank the organizers for inviting us here for this very intriguing subject, which is a very high-tech and, if I can call it deep tech. And the topic of responsive launch and on-orbit servicing, this is a topic that will, take the country, that will leapfrog the country as far as security architecture is concerned. That is core of this particular seminar. But as well, this is a dual use capability when we talk of responsive launch and on-orbit servicing. First of all, responsive launch, people confuse with launch on demand. I will tell you the subtle differences between the two. When you talk of responsive launch, this means you launch when you choose to launch. You don't launch when you can launch. So you choose to launch, and that is responsive launch. So the key factor here is speed. When you talk of launch on demand, here when you have a demand you launch, but in that case certain parameters have to align, and hence for launch on demand, readiness is a key issue. But we use it in the sense both words, so there are similar capabilities but subtle differences. So responsive launch or launch on demand, if we can use it in the same sentence, then what is required, the characteristics that we have to understand, those are extremely important to achieve this capability. And the characteristics for this capability is speed, precision, flexibility, and concealment. Only if you follow these 4 particular parameters, your responsive launch can be a success. So the next question that comes to mind, that if it is that important, then why many countries in the world are not doing it? Because very few countries have this capability. Rather, if you open space news, you will find every second, third day an article appearing on the responsive launch or launch on demand, because it can be debated both sides. Do we require it or we don't require it? So when you talk of responsive launch, the issues that come to mind, that how we should go about it. Should we go about it when our satellite numbers are already limited? And are we waiting for responsive launch or launch on demand, or we are launching satellites to increase the number? When we have this capability, for example, a satellite is launched, and it's till the time it starts beaming down data, the satellite has to stabilize itself. So that will take some time, which means after the launch, it can be from few days to few weeks. So how does it fit in the overall operational matrix? Now, who should do it? Since it has got strategic implications, should it be ISRO, DRDO, or should it be private industry, or should there be a handshake between the private industry and the government? So all these questions, that come to our mind, probably we will try to address them as far as this panel discussion is concerned. And the second very relevant topic is on-orbit servicing. Now, on-orbit servicing is a topic that is gathering momentum the world over. Once again, a very high-tech domain. Very few countries in the world have achieved it. Why this is important? Because the constellation size is increasing, number of constellations are increasing. If there are 10,000 satellites today and you open Google, there are all kind of numbers which going up to 1 lakh by 2030. Also, the fact remains that the space is a very expensive domain. The gestation periods are very long. In other words, idea to orbit time is very long and it is an expensive domain. The implication of this particular statement is that the satellites in space, I would like to maintain them, refuel them, overhaul them, and carry out whatever possible to extend their life cycle, whether it is, and they have got n number of use cases, even strategically, that we will not talk in this particular forum. So on-orbit servicing and maintenance is a capability that will again take the country forward, and it is once again a dual use capability like the first one. So the panelists sitting here, they have great amount of experience in this particular domain. So now we will try to, so now I'll hand over and go from one panelist to another. So, Mr. Srinath, if I can come back to you as a first panelist. Like I said, I gave the introduction as far as responsive launch is concerned, and there are there are the proponents of responsive launch and there are the opponents of responsive launch, because there are considerations both sides. So if I can ask you, and you are the professional, in this particular domain, and you are getting onto this capability, how do you see it coming up? And what model would you like to suggest? Any recommendations, any challenges as part of this, as part of this seminar, the report that will go upward to the strategic community? Do you want any recommendations? So over to you.
Yeah. Thank you, sir, for having me here. So I'm Srinath, one of the co-founders of this company called AgniKul, where we build rockets that have the capacity to take up to half a ton, at least today half a ton, to low Earth orbit. So responsive launch actually has been a part of our strategy, even from a commercial standpoint, for a very long time, right? And we actually approach it in two ways. One is at the design stage of the rocket, right? You can't solve for too much only in operations. So you will have to keep a few things in mind at the design stage. And then as we learn with every launch operations is very different from making the rocket itself. So a few things have to be done on the operation side as well. So let me talk about both of those topics, right? And I'll use our own rockets, Agni-Ban, as an example for both of these. So the first thing that usually prevents people from getting to a responsive launch, meaning you want a launch and you want to do it when you want. The first problem that usually people face is the ability to have the hardware available. Right now, if you're looking at the propellant combination, for example, solid propellants versus liquid propellants, there is always that risk that comes with solid propellants in terms of you can never exactly fly the hardware that that you will be flying. Once you test it, that's gone. So you will have to do something like take that execution risk every time, right? But we've done it a few times in the country, so we know what it means to fly solid propellants. But that execution risk continues to exist. We just saw that with, unfortunately, the recent PSLV failures as well. So one approach for us was to choose liquids, because once I test a stage and leave it aside, the same stage will fly. So I have very less, risk in terms of getting something to flight itself. Then in terms of at the design stage, looking at how complex it is to actually get a launch done from a design standpoint. Like for example, choosing fuel combinations that are hard to come by, right? Say for us, what we are very clear about is all we need to launch is an airport nearby from where we can get aviation turbine fuel, the standard fuel that goes into any, plane, and liquid oxygen of industrial grade. So by solving for propellants that are easily available, again, you make the responsiveness a little better. You're not looking at one more set of things to be done to actually, make your vehicle fly. So that is again solving for the fuel level. Now, once these two aspects at the design stage are taken care of, there's a third aspect, which is, the payload or whatever we want to actually put in orbit. If it happens to be a very small fraction of what was actually originally the rocket was designed for, or, if it is not optimal, sometimes your rocket's dynamic characteristics start to change. The rocket starts to become a little more vulnerable to higher frequency vibrations and so on. Your last stage, the upper stage I'm talking about. So it's important to be able to build vehicles or launch vehicles where even for the lower end of the spectrum, usually launch vehicles operate in a range. It's better to keep that range as wide as possible with the same configuration, so that you're not again looking at, I'm short of 100 kgs or I'm short of 500 kgs, and hence this is slightly more prone to failure and so on. So that was something that we again configured into our rocket itself. So I would say these three things come in from a design standpoint. Choice of fuel, choice of propulsion system, and then choice of having the flexibility to play with the carrying capacity of the rocket. Now on the other side, now coming to the pure launch operation side, I think the transportability of the rocket and in fact the launch pad hardware itself is important, because depending upon the reason why we want that responsive launch to happen, we may have access to the launch pad we want, or we may not be able to. We may not be able to transport certain things on the road for prolonged periods of time. We should not have too much restrictions on the speed at which things can be moved on the road. And these things again become a function of the propellant combinations we chose, the overall safety levels of the systems we use. For example, if rocket hardware that we are flying is explosive in nature, even before it gets to the launch pad, because of certain pyrotechnic devices we have used, or because of the solid propellants we're using, that becomes a problem. Right? You're much rather better off with hardware that is benign, that feels like a piece of metallic systems, composite systems, until it gets to the pad and is filled with fuel, at which point the whole thing becomes an active operational system. So that transportability part from both a safety standpoint and handling standpoint is important. Next, I think would be in terms of how you think about the concept of the operations of how you will get the launch done. So starting from how it is modularized and transported, can we fit it into regular cargo containers, right? Can we fit it into regular width of lanes? Do we need to close traffic for this? How quiet are we in getting this through? Or what is the least amount of disturbance we can create to get this to anywhere we want? I think those are other conditions that apply again in terms of responsiveness. Otherwise, this becomes its own burden or its own obstacle in terms of getting things through. You can't move your hardware during the day sometimes. You'll have to only keep your speed limit to 20 kilometers per hour or 10 kilometers per hour, which means then again your production will have to be close to a particular launch site. I think all of these things can be avoided if at the design stage we already solve for this being a part of standard cargo containers, where your systems are already prone or immune to a certain level of vibration and so on. So I think that will be the aspect from a rocket transportation standpoint. And then finally the launch pad transportation standpoint, right? Particularly when you're looking at smaller rockets, I would say any rockets with a carrying capacity of less than 1 ton, we honestly believe, and we've done a lot of work on this, in making sure the entirety of the launch apparatus is also taken from place to place. This includes the mission control room, this includes the tracking flight radars, this includes the fuel propellant plumbing lines, this includes the pressure systems, this includes the power systems. These can be designed and modularized in a way where all of this is just a bunch of cargo containers. So you have a fleet of 10-15 cargo containers that are moving along with your rocket, which is probably in another 2 or 3 cargo containers as sections. You go to wherever you want, whichever is the right location for the launch, which obviously we sort of pre-decided that to some level before, and then you go there and get the launch there and come back. I think that is that level of readiness in operation and design is what is needed to make this whole responsive thing happen. Now again, across the world, if we look at, and this talking about your last points of why are other countries not doing it, there are, I think, like 6 countries across the world which can do orbital launches today, if I'm not mistaken, right? And India is in one of them, which we should feel great about. Literally only 6 groups of people across the world know how to build an orbital class rocket. It's a very specialized skill that way, right? And within that, the focus on responsive launch has only now picked up a little more, and I think still most of them are figuring out what it means to get that to work from an actual operation standpoint, both when it is needed from a time level and from a cost level. So, but my point again to summarize is there are changes to be done, or there are parameters to be kept in mind at the design stage. There are parameters to be kept in mind at the operation stage, and with this you can address both the time aspect of it and the operational complexity aspect of it, and only then an actual responsive launch is possible.
Thank you so much, Srinath, for bringing out all this. I think the key takeaways, as far as Srinath is concerned, I foresee 4 critical key takeaways. First is that if one wants to get into this capability, the planning and the operationalization has to be in the design stage itself. Second is access to the launch pad. Third is transporting systems, because how do we transport in containers from place A to place B to minimize time? And last point is that since we are very close to developing this capability, this dual use capability, I think it can take the country forward in a very big manner. So this is one capability where we should be talking of cooperation and collaboration with international partners. So thank you so much, Srinath. I have got a couple of questions, but probably will come in the next round. Mr. Ashok, if I can now, ask you to cover your views on responsive launch and on-orbit servicing, especially in the field which you are in. And also, how do you think that it should happen, and cover any challenges and recommendations?
Thank you very much. Good morning to all of you, and I thank SIA again for giving me a chance to be on this very eminent panel, as well as delegates, So I will, on the first question of responsive launch, I'll give a slightly different angle or viewpoint, Now, fundamentally, if we take one step backward, okay, why do you need a responsive launch, okay? It's because defense systems have to be resilient. And in order to be resilient, if there is a failure of any kind, natural or by an adversary, then we need a rapid reconstitution. That means we need the capabilities to be restored as soon as possible, okay? Now, when it comes to rapid launches, there are many constraints, and some of which have been discussed here. But beyond that, one has to look at the launch window. One has to look at when the satellite will be in position. Because especially if it's a geosynchronous satellite, it may take weeks for it to drift into the correct position. So we have lost the ability to perform the function for many weeks. So my answer to a responsive launch is to have satellite spares in orbit. Okay, so they are there and they can be activated in hours and maybe days maximum. So that's why I said I'll take a different angle or a response to a responsive launch. Now, when it comes to on-orbit maintenance, that is a subject close to our heart, to my heart, and what the company does. In the last time somebody said that, well, you never said what your company did. So in this case, it is actually relevant, that we talk about on-orbit maintenance. And there are two aspects of it. One of it is electronic and mechanical maintenance of a satellite, and the other one is refueling. Okay, so let me first talk about refueling. Now, we are designing and working on what we call an M4V, say multi-mission modular maneuverable vehicle. So it does many functions, and it comes with a green propulsion system which has a refill valve. So it can be refueled in space. But now when we look at the practical aspects, while everybody talks about refueling, how is it really going to happen, okay? It does not make sense to send another satellite up to refuel it, because that costs a lot of money also, So the solution, hypothetically, is really to have a depot in space, okay? So there is a fuel tanker which stores the fuel, and little ferries take the fuel from that tanker to refuel our or some other satellite. Now the thing is, okay, what kind of fuel will it store? Will it have all kinds of fuels, some fuels? Will it have cryogenic fuel? If it has cryogenic fuel, how is it going to be kept cool in space, So these are all challenges, and I think this, while the goal is noble, but I think that refueling as a practical happening is going to take some time. There are a lot of technical and administrative things to be taken care of. Now, in terms of maintenance, okay, that is, we go up and we have done a lot of work in this area also. For example, I mean, our vehicle can serve as an OTV. It can be a RPO and RPOD type of vehicle. And we have also developed techniques for autonomous collision avoidance. So if you're going from one place to the other, and I may be wrong, but I don't think anybody except SpaceX does that. But we have developed the capability to do autonomous collision avoidance. We also need to be, for docking and things like that, we need to be able to determine, especially determine the relative distance and the orientation of a different object, And we have developed techniques to be able to do it during daylight, and we are now developing techniques to be able to determine this during nighttime. So even in the dark, we want to be able to have the capability to be able to dock or see where the other object is pointing, We have been working on a robotic arm, and we are just beginning to start on a navigation suite. Because there's two aspects of navigation. One is navigation in terms of the big orbit, that the satellite may be taking, and the other is navigation of the robotic arm. Okay, we need to be able to guide the robotic arm correct to about 2 or 3 millimeters in space, whether it's dark, light, hot, or cold. So that's something that we've just started working on. But I believe that maintenance and repair in terms of mechanical or electrical maintenance will happen much before, or definitely before refueling, Thank you.
Thank you so much, Mr. Ashok. And I thank you for bringing out the points that you really brought out, although, this is a different thought process, but I think extremely valid point. And that is what many countries in the world are doing, having, spare orbital satellites. This is a different viewpoint, and I think we should really develop on it. And I think that is the reason, you find any GNSS constellation, if I can take an example, whether it is GPS, Galileo, or GLONASS, each orbital plane has got spare number of satellites. So, I think that is a great point from that perspective. As well as tanker in space, having a refueler in space. Once again, I think a different perspective. If time permits, I would request you to throw some light on automatic collision avoidance, that you mentioned. And I think personally that the kind of capabilities that he mentioned and Srinath mentioned. So like I said in the beginning, these are niche capabilities. And I think one of the purposes of this seminar should be that how we get these niche capabilities, especially the ones that are dual use. Because that is the one that is going to take the country forward, and I think that should be a key takeaway as far as the seminar is concerned. But we'll fall back on this later. So, Jay, now from Aule space, if I can come to you, since you are a key player in on-orbit service, if you can cover from your perspective, because once again this is a capability that we are really looking at. Your perspective of it, also with the challenges that you are facing, if you have to ask, let's say 1, 2, 3, what would you like to ask, and how this, how the government and other bodies can help you out. Over to you.
Hello, yeah. So whoever was here for the panel yesterday, sorry for some repetition that I'll do in the content, but I would like to start by giving a bit of a background on on-orbit servicing, then jumping into the strategic and responsive nature of it, and then coming to the challenges we are facing and things which would be helpful for us. So in 1984, there was a satellite which was launched on the path to GEO, but it ran out of fuel and NASA had to spend $1 billion. They literally sent astronauts up to grab the satellite, bring it back, and then refuel and launch it again. That was obviously not scalable towards all the satellites in space, like doing a refueling of this nature if something goes wrong, or in general any maintenance requirement is not feasible, and the business case would never stack up. But today, because of the technological shifts, we are on a inflection point where computer vision has taken so much leap that with just cameras you can figure out where the satellite is pointing, how far it is from a given set point. Robotics has taken a leap. We are flying GPUs in space now. So because of all of it coming together, there's a business case that stands for servicing things in space, and it spans from servicing all the way to assembling things in space, and also refueling satellites in space. Coming to the strategic side of it, defense always likes to have readiness for any unforeseen scenario, and the technology has both civilian use cases but also defense use cases. There can be offensive nature of satellite which can come and harm existing satellites in space, and that calls other players to have their own army of satellites in space to be responsive to it, to be defensive to it. And a launch, as we discussed, like even though we optimize it a lot, it takes time. And what in that case can help is having satellites on standby in orbit. And we recently did some number crunching and came to the conclusion that with just 30 satellites placed very strategically, we can cover 80% of the satellites in space, such that we can reach them within a day time if we want to reach to a certain number of them. And all of this is powered by the autonomy, which recently came in because of the technological shifts. And we at Aule believe the starting point for this entire economy of being able to go and dock to satellites and service them will start by us cracking docking first. In India, we've done only one mission till now, which is the SpaceX mission, where we docked 2 satellites. We want to make it more of a routine thing because there's an adoption problem in the market. There's no interface with heritage with which people can adopt on their satellites. And that will require someone to first go and dock 2 satellites and make the heritage for it, that this is a reliable technology. And then all the other use cases spring out of it, be it refueling, servicing. If you can go close and grab a satellite, everything unlocks. In terms of challenges, I think yesterday also we spoke about the regulations. Since this is a very new area, the regulations are also not very well formed. It will take some time, some missions to know what goes wrong, what does not go wrong, and shape the entire regulations around it. But one of the biggest concern is obviously debris generation. Whenever you are going close to an object in space, there's a chance that from an engineering standpoint, we try not to do it, but there's a risk that the satellites collide and create debris in space. So it requires the government support to back private companies and trust them to take this endeavor because of the potential upside it can create in terms of the new technologies and use cases. Today, there's no checklist of things that we can go through if you want to go and dock 2 satellites in space. As well as it's very hard to get spectrum licenses, specifically in the geo orbit where most of these high-value satellites are, which make a very good business case for the life extension. So yeah, these are some of the points, and if you have any follow-up questions, I'll take them.
Thank you so much, Jay, for bringing out the historical perspective and key takeaways. As far as Jay is concerned, I think he spoke about the offensive, if I can use that word in italics, capabilities, which of course the capability has. But more importantly, I think if we come back to the civil domain, till the time we can inspect a satellite, maintain it, refuel it to increase its life cycle, that itself is a huge capability. I think a very important point that you brought out is how many satellites like this should be in space to cover the complete architecture as far as the country is concerned. And moment you do that, of course, you are pitching it up at the global scale. So good point from that perspective. I think the takeaway should be that we do calculate, which I don't think we have done, that how many number of satellites we should have in space. Regulations, I think a very pertinent topic we have discussed at length. And also, although you mentioned in passing, I think that should be another key takeaway as far as the seminar is concerned, is for capabilities like this, we have to have we have to have bodies like ISRO holding hand of the young startups working in this domain, because these are niche capabilities, and that is how all the global players are doing. So before we, that is as far as the panel is concerned. But before we get into question answers internally, I think since it is a panel discussion, in case there are any questions from the audience, we will like to take on that first.
So you mentioned that you have to have limitation on the number of satellites. Are you talking about the all satellites, or are you talking about the maintenance satellites?
So here we were talking about the maintenance satellites. How many should be there?
I don't have a question, Pawan. I have an observation, if I may. So this is the first technology we are developing, or in fact internationally, which is space to space. We are now moving beyond satellites that are providing military services down on Earth. For this, as Jay has pointed out, we have done that SpaceX mission last year in January. What is required is two types of regulations. One are technical regulations, which is what is the domain expertise of our space agency, and therefore the in-space. This is what they have done already for other things, such as launch and for satellites, our remote sensing, Earth observation, and communication. They have not as yet got technical regulations in place. I do not know whether the writing is as we speak, but to the best of my knowledge, it is not available. Now the thing is this, that this is a whole new technology. This means that if the government, that is to say civil and military together, wish to develop this technology, then you need to sit together and have a systematic, methodical roadmap for exactly how you're going to encourage these companies to do. And this means you have to understand not only the spectrum issue, but what will be the kind of experimental licenses that you will provide them. What will be that point of traction where you say, okay, experiment stage 1 you have completed, on orbit I mean, and now we will do the second, which is that we, the state, has X number of satellites at that particular altitude in that particular orbit. And we are prepared to give you a contract to go and refuel or whatever else that you're looking to. One thing at a time is a good idea though. So we are prepared to give you that satellite for refueling, and we will bear the cost in case there is a liability, there is damage caused in space. That regulatory aspect, technical regulatory aspect, automatically takes care of the many legal conundrums that will arise and will have to be factored in if the company wants to go commercial. So without a roadmap, if you're going to rely on them, and there'll be, so the government will have to step in, means the civil and military will have to step in. And they will have to have a systematic step-by-step road. It is not going to happen tomorrow. You know that the earliest companies, Sri is over here, these have been incorporated long before the space reforms. They are now at a stage of undertaking orbital experiments, and then all our first generation companies are now in maturity phase. It will take them another 3 to 5 years to go commercial. That's how long it takes. So civil and military must together support development of this. This is new technology, and there are serious legal implications under the Outer Space Treaty, which while writing, Your technical regs, you must know. You can't say, no, I'm not bothered about the legal part. I only deal with ops. It won't work like that.
Thank you so much, ma'am. Thank you so much. I think a very important point, like you said, when the Outer Space Treaty was written in 1967, all this didn't exist. And I think more important point, like you mentioned, and to be very, to be factually correct, we have been focusing more on Earth observation. Non-terrestrial space to space is something that probably as far as the government is concerned, we've talked about SpaceX mission and all that. So I think the roadmap to develop that space to space capability along with the legal and technical regulations is a very important key takeaway, and thanks for that, ma'am. Bedi sir?
Yeah, Air Marshal Bedi. No, great capability, responsive launch, and we have been talking about it. Now, I, as a military practitioner, would just like to bring out the counter to the flip side of it. Okay, now there are two problems that are likely to be created by this capability or this thought, one for military, one for industry. In military, what happens is moment military thinks of responsive launch, it thinks of very short time frame. It is like reducing OODA loop, quick reaction kind of thing. But here things are different. The challenges which have been brought out, if something is going to become operational, let's say after 3 weeks or 1 month, then it's not the response time really military is looking at. And also, my worry is that let's say we start demanding this responsive launch very, very urgently, then industry somehow will start falling in line and start offering that, okay, yes, we can do. No industry wants to be left behind. So when they start promising, okay, yes, we can do a responsive launch within whatever time frame you're saying, without really showing credible control over the challenges, like availability of fuel, the filing, ITU filing, etc., then when you actually want to launch it, you may not really have it, okay? Having something in orbit, like Mr. Saxena said, Navy takes carrier right into the sea because they are not depending on something to be launched from onshore now. So it's a, good thought. And for the industry, now, armed forces or the military, okay, the biggest user of space as of now here, I mean, from intelligence point of view, if gets comfortable with responsive launch, they may not plan, we'll fall into that emergency procurement cycle, where your normal procurements now backseat, and whenever something happens, you get into emergency procurement. And you're comfortable with the idea that, yeah, okay, Srinath will launch whenever I want, so why unnecessarily launch it? So what happens is, with that now, how will industry map its growth and see that at what rate are we, everybody is sitting with some satellites ready, waiting for that, order to come that now is the response time, now I will launch. So I think we need to keep this in mind when we propagate this concept.
Sir, thank you so much. Actually, that is a very important point. And Srinath, before we come to him for the question, because this is a general question, that people have, that the response time, when you say, responsive launch, it is in response to a situation. But in the sense, by the time you plan it and you get this capability, there is a wide gap in between. So that is a very important point, which lets you believe that let's get onto the satellites in orbit as spare satellites, and do we require this capability? So if I can, if I can request you to just develop on that.
So I think from a responsiveness standpoint, if we can talk about like some discrete time periods of waiting, right? Say starting from 1 day to 1 week to 1 month. Let's say that's 2-3 scales of times we look at for waiting periods. We need to have a framework for saying how many different launch points can we launch from, and some preliminary work has to be done and kept ready from a readiness standpoint. So let's say you're talking about 2 weeks. It's not that. Oh, sorry. It's better now. Yeah. So from a 2 weeks and 1 month standpoint, I think if that is the kind of time frame we're looking at, then you can pretty much be in 3 or 4 places in the country and then get to anywhere and do the launch. I think that kind of time frame is available. If you're talking about less than 2 weeks, particularly if you're talking about 1 day, 24 hours, 12 hours, then I think the only way to really solve that problem is to already identify the kind of missions we'll have to fly. It's not it's not a continuous spectrum. We can't do any launch in that kind of a time frame. It's simply not possible in my understanding. But you can choose about, say, 20 different types of launches you can execute. This 20 would be divided across launch locations and across orbits and across satellites, right? Some permit, say 4x4x4 or something of that sort, right? You can have a matrix of particular launches and you pull off one of those in that time frame. So I think once you go to that kind of a time frame, that systematic framework is required at a country level. We don't need to publicize it. We don't need to be actively talking about it. But it is a finite set of launches that are going to be possible. But the moment you relax it to even 2 weeks or 1 month, I think pretty much any launch is possible if some of these other points are addressed, right? If the vehicle is movable, if the launch pad is movable, if the fuel combination is easy to get, if it is not a hazardous system, then these 2 weeks and 1 month kind of responsivenesses are possible. Less than that, you have a finite set of options. That's what I'm trying to say. So, but we should plan for that. So that it is not a surprise. One of these will have to be taken out and done, depending upon the reason for that, launch.
Thank you so much. Thank you. We'll just come to him before he comes because he raised hand first.
Hello, thank you. So I just want to build on some of these comments from my fellow audience members here and ask about the D word that I did not hear. So I heard the dual use word, but I didn't hear the demand word, right? So I think when we are talking about on-orbit servicing and responsive launch, yes, regulations are super important. Yes, the engineering considerations, of course, are super important. And on the regulation side, I think to the debris generation point, these collisions, they're more like bumps, really, right? That's what we're talking about. If you're getting to within some distance and then you're doing a centimeters per second approach, like that's not a hypervelocity collision. That presents different challenges. And yes, per the Outer Space Treaty, you do need to think about how you can be responsible there. And there are some interesting capabilities, I think, that sort of, in the US at least, for regulatory support, happy to talk about this, that are being developed. But I think the demand question is fundamental. Because for on-orbit servicing, what are we talking about? Are we talking about geo birds? Because if we're talking about geo satellites, there's not that many of them. They live a long time. They will not be refreshed that often to begin with. The market is only so big. When we talk about LEO satellites, who wants to actually refresh their LEO satellites, keeping them on orbit with old technology, instead of changing the technology cadence by just launching a new one? SpaceX doesn't do this. Amazon LEO doesn't do this. Blue Origin TerraWave isn't talking about this, right? None of the big constellation operators who would be customers for this are interested in this technology stack for LEO, right? And so then we have this question of, okay, you build it. If you build it, they will not come. You have to build to what they need, or else you have to create the demand, start from the end, and then let the market come to meet it. And I think there's a similar sort of challenge for launch. And so this is why I'm very glad that you've distinguished between sort of tactically responsive launch on the day time scale versus launch, when you need to on the month and so forth time scales. But even there again, right? How do you think about the demand that is going to pay for the fixed costs of all of these developments? You want to have liquid rocket motors? Okay, well, that is a development cost. You want to have movable launch pads? That is another infrastructure cost. Payload processing facilities is another infrastructural cost. All of these things someone has to pay for. And if you are having one launch every month, that is probably not enough demand to actually cover the standing army costs of building this out. And so I'm sort of curious how you all are thinking about this, because what we have seen elsewhere is that often it is the defense or the government customer who creates the anchor demand. But I haven't yet heard of, say, an Indian proliferated constellation that will use servicing, or I don't know what these sort of demand considerations are. So I'd be curious to hear from the panelists how you think about this.
Thanks. I think the point that he wants to bring out, if I understand is right, he is talking about the demand as far as the on-orbit servicing is concerned. And, if I have to, argue in his favor, what he is saying is that, if we want to, let's say, refuel the satellites in GEO or LEO, they were launched a couple of years ago, so the technology is older. So what is the requirement? So Jay, in case you want to answer it before I cover my perspective, over to you.
All right, yeah. So I think I'll leave the defense side of things on you, sir. There is interest, and we have in talks with Indian defense for this capability globally. Obviously, defense demand is there. On the commercial side, just to tell you what we have been seeing on the commercial side. There are geocommunication satellites which are not affected by the technology being old, and they are still generating like around $50 to $100 million in revenue every year. These are the satellites which make a compelling business case for life extension. I'm talking about existing satellites, not making a case for like satellites where we put a refueling fuel today, after 10 years we refuel, and who knows what will happen after 10 years. But just today, if you see, there are satellites worth over $100 billion just in the commercial communication satellite category. It's not even like satellites owned by the defense that I'm counting in this pool. And for them, on the satellites which are on the higher side, it makes a compelling business case for life extension. The number is small, but if you look at the current trends, Northrop Grumman has 2 mission extension vehicles in orbit. They're launching a third one this year, which will have 3 MEP pods. They will attach a pod to 3 satellites, which will extend their life. Starfish Space has signed a contract with SES. Infinite Orbits has signed a contract with SES. So as we speak, next year there will be 7 life extension missions ongoing. So it's not like there's no demand. The demand is clearly there and it's picking up. The industry, I feel, was in a chicken and egg problem where no one had demonstrated it, and thus no one was ready to adopt it. But since the first mission that happened in 2020 by Northrop Grumman, which is the only company in the world that has done a successful docking and life extension mission, since 2020, this has taken up, and now we are seeing the demand on the commercial side. And as for the future, this technology is a foundational stack. It's about making autonomy stack for space. It's not just limited to life extension of geo birds, but in LEO as well. As we build bigger, large-scale structures in orbit, all of this technology will be used there.
Thanks so much. So I think the demand does exist. Use cases do exist as far as on-orbit servicing is concerned. There are n number of use cases, that dual use capability. I don't think we should get into use cases as far as strategic community is concerned. That is not the scope here. But as far as commercial applications are concerned, there are n number of use cases, right? So, Srinath, so if I can ask you just to take 30 seconds to a minute to cover his perspective of demand as far as responsive launch is concerned.
So I think I'll divide into 2 parts. One is on the capability and capacity development. The other one is actually commercializing or making money out of it. In space, one thing in the last 8 years of running AgniKul I've been surprised about is the kind of applications that are coming up. Remember talking about data centers in orbit in 2019, and then now suddenly after 6 years it seems to be the talk of the town in the US, right? And this just makes me realize that talking about responsive launch is more like getting a key to a door that you could open when you want. So I'm dividing your question into 2 parts. Technology development and capability development, and keeping that ready. You don't need to keep doing that, and that's where the actual commercialization and the big chunks of money are going to come in, right? But who knows when the need actually will come. At that point in time, given anything in this sector, given the life cycle time it takes to develop something, it is too late to start when you know you need it, right? And it's something we will have to take that. We'll have to have the foresight, or at least the bet. It's pretty much a bet or a gamble, I would say, to say this is going to be needed one way or the other. We may as well do it when we don't have the time pressure. Keep it ready, keep it operational, and go full throttle on it when there is an actual need, because we can't start when there is a need. That I think would be too late. So that's I think the big answer to the technology part itself. Commercially, I do see applications for crisis and so on, but again, going back to let's get the tech ready. We are talking about capacity building and then commercializing as and when it takes.
Right. Thanks, Srinath. Sir, a quick point. Just 30 seconds if I can ask you.
Okay. Okay, I had just a couple of 2-3 points which I'll do very quickly. First of all, I had a team of people working on the Northrop Grumman maintenance and repair mission 7 years ago, okay? So I know how long it takes for something to happen, So to a large extent, I agree that the market is not so big and it takes time for things to mature. But that's why we call our solution the M4V, the multi-mission modular maneuverable vehicle. It does many things, okay? I mean, for example, building structures in space is going to happen in the near future. Especially they need big radars, in space, okay? And that you can do only by assembling them. And there are other applications of assembling. And there are other applications of the vehicle, okay? The last thing I will say is that Steve Jobs once said that it's not the customer's job to know what they need, okay? So unless you show a capability to them, they won't realize what they've been missing, When he came up with the iPod or the iPad, nobody expected, so what is this for, And now, so many decades later, you see how popular they are.
Thank you so much.
Sir, I had an observation regarding this on-orbit servicing. There's already a dev space challenge on that. But how are you looking at standardization of ports? Talking of so many satellites being launched, because even the NAVIC, when it's getting launched, one satellite is going to be different from the other. And so on one hand, it is fine to talk of on-board servicing, but simple thing like ports standardization. You have companies like Inspect City and Orbit doing a good job in this. So I think we need to have this standardization of ports across all satellites being launched across all companies here on. Secondly, I have a question for Srinath. AgniKul was working on a launch on demand thing regarding the naval listing. So is there any progress on that?
Yeah, that proposal is still very much intact. We will be working on the development of that once we get this next commercial mission out, which is going to be a land-based mission. But I think because from the beginning we have been talking about mobile launch pads, the ability to think of the launch pad itself as a moving thing has always been there. It has been the core part of our thought process. So that part is something we'll work on after this mission. But there's a reasonably detailed design that already exists. One thing that has also helped us is in the upcoming mission, which I think we'll do between October or so, somewhere in that range. We are planning to get the booster, the lower part of the rocket, back to a barge. So there is a lot of understanding now on what it means to operationalize these systems from a floating platform standpoint. What kind of stabilization is required? What kind of weather would permit it? What about the winds in that area and so on? So I think this would also naturally, will allow us to build a knowledge pool that we can use for the ascent part from a sea-based platform.
And point taken for standardization, very important point. So any other
Standardization, very true. The key is really to standardize the docking adapter, okay? And I know the US has a standard, the Russian has a standard, but we also need to establish a standard, at least for India, but hopefully universally.
Just opportunity that I want to make an announcement to the industry to say that if anybody wants to interface with the Army Design Bureau, please, you can contact me. We will constantly keep feeding to Army Design Bureau. If you have something, if you think in the roadmap, you see some light and you can collaborate, so you can keep contacting me and we will interface with the Army Design Bureau. Similarly, we can do with the Navy and the Air Force also. Because yesterday industry had a lot of query, so you can contact me whenever, whatever.
Definitely. So I think, MC has already indicated that we need to wind up. So the very fact, the kind of question answers, the kind of question session that we had, it shows, it shows how different these topics are as compared to routine topics. And the kind of interest and the capability that can be generated for the country. Although there were key takeaways that I covered after each panelist had covered his part, but if I have to sum up the session, so I'll just cover 3-4 main issues. First and most important is, I think internally, between the government and the civilian side, we need to sit together and make a SOP as far as responsive launch and on-orbit servicing is concerned, because there are pros and cons both sides and it can be debated either side. But I think we need to come together and be on the same platform. Second is the roadmap. A roadmap has to be made to encourage the niche capabilities that we are trying to develop, because these are the capabilities that India can use to lead the global south. If we want to build a capability wherein we lead the global south, at least global south, if not a major space player, I think then we have to focus on the niche capabilities and like these. And that brings me to the third point, that for niche capabilities like this, I think, the major PSUs should be holding hand, because, whether you talk of test facilities, etc., those are available only in that domain. And lastly, I think as a country, we are really galloping as far as space is concerned. So we have our international partners sitting here. I think, like the government has brought out, I think we'll be more than happy to co-design, co-build, cooperate and collaborate. So that is it from our side. I would like to thank all the panelists and thank the audience for these question answers.
Thank you very much indeed, sir. Before we close the proceedings, may I request Air Vice Marshal Pawan Kumar to kindly do the honors of presenting mementos as a token of appreciation to our distinguished panelists. We present to Mr. Srinath Ravichandran, co-founder and CEO, AgniKul. Thank you, sir, for all those valuable insights you shared. To Mr. Ashok Saxena, CEO Space TS. Thank you, sir, for agreeing to joining the panel at the very last minute and for all those valuable insights we had from you. Thank you. And to Mr. Panchal, CEO Aule Space. And may I invite on stage General Panu to kindly do the honors of felicitating our distinguished moderator, Air Vice Marshal Pawan Kumar. Thank you very much indeed, sir. Thank you, General Panu, for doing the honors. May I request for a group photograph of our panelists. And ladies and gentlemen, requesting everyone to kindly remain seated. We are straight away moving into the proceedings of the next panel discussion. We will request just a few minutes to arrange the top table for the next session.
Thank you so much, sir. Thank you. Thank you, ma'am. Thank you so much. Thank you, sir.